Then we can move on to light mapping. First of all, with light mapping, what it basically does, and I can show you somewhere here, I have an example. Okay, so here's my example. When you light map something, you basically render out a texture with the lighting information and you blend that on top of the mesh. That's all it really does. So the mesh by default looks this is the diffuse texture on it. When you light it and you bake the light mapping on top of it, it makes a light map texture and it multiplies that on top of the diffuse texture until it looks like that. You can see I have a cube here. That cube has one light here and there's a little pillar standing here to get a shadow coming off it. There's a green light and there's an orange light. Now if you look at the light map that Unreal made for this, and you can see the light maps if you go to the content browser, and if you then click on the package with the name of the level, so then the levels actually also show up in the content browser, you can then see the contents of that, which is usually mostly light maps. So these are light maps found in this level. And you can clearly see that, for example, this one is the light map made for cube. You see, this is the top face, this is the bottom, and the green part here is this side. The other parts are black, so they don't really show up over here. So this is the light map it makes, and this is basically just multiplies this image on top of the existing materials. Okay, so that's the basic of light mapping. I'm sure everyone knew that. But then what's special about doing this is that you have to tell the mesh how to make this image. You have to tell the engine how to generate, how to render this light map. He has to know the layout of how to unwrap, unfold the polygons of this on the UVs basically. In other words, you need to make light map UVs. So what I have here is I have a cube. Actually, let's do this cube again. I'll make a new cube in similar style as the one I have over in my level. So I'll just make a 512 512 cube. Like that. I'll call it light map test. And what you're supposed to do then is unwrap it. So when I add an unwrap UVW, this drops a bit off the resolution, but see if I can do this. It says here map channel 2. It will say 1 for you, because I changed the default from 1 to 2. But change the 1, so this is what you will have. Change the 1 to 2. Then we'll get a box. Do you really want to do this? Do you want to move it or abandon it? I'm going to abandon it. Then it will forget what was in the first one. Not really forget it, but it's not going to bring it along to the second channel, which is good. And now any UVs we edit will be edited on the second map channel. Now in Maya, these are called UV sets. So in Maya, you would create a new UV set somewhere in the top menu of the unwrap window. Create a new UV set and work on that second UV set. And the thing with map channels and UV sets is that it allows you to make a completely different UV layout that's completely different from the diffuse UV coordinates. So for example, this, if I were to simply flatten this, and this is what I usually do when I light map things, is I simply flatten it like that. It's not ideal, but it's a start. If I do this, this is now my second UV channel. If I close that and I add another unwrap UVW on top, make sure you really add another one on top and don't edit the existing one, because then you lose what you just did. So I add a second one on top. And then I look at channel 1 again. So I change that 1 back to 2. Again, I do abandon. And I click open UV editor again. Then you can see it looks like this. So this is the diffuse texturing. If I change this, then that's how the diffuse texture looks, right? But changing this has no impact on the light map UVs. This is again channel 2. I added a new one. Look at this again. And as you can see, it's this layout again. So you really have two entirely independent UV layouts to work with. And that's very important because you, of course, you don't really want to light map the mesh based on the diffuse UV coordinates. You need to have specific UV coordinates made just for the light map. And why does it have to be specific? Well, it has to be specific because, first of all, Lightmap UV coordinates may never go outside the 0, here is 0, to 1 range. So it may never go outside this square. The moment it does this, you have a problem. That's thing 1. Also, every single face on a Lightmap UV layout must have its own unique space. You can't do this, for example. You can't overlap one face with the other. Even if they're supposed to share the same diffuse texture in that area or whatever, you can never overlap whatsoever. You can't even overlap the tiniest amount. This is still wrong. So absolutely every single face must have its own dedicated space within this square. Those are the basic guidelines. And if you were to do that, and this is correct, I did a simple flatten earlier, so it's correct. Nothing touches anything, or at least it doesn't overlap it. So here we have a basic UV layout for the light map. So let's try to put that in the engine and see what happens. I'll quickly do, or I can add it just here. Okay, so here's our box. You can see the diffuse changed. It doesn't look like this cube, for example, because I was messing with the diffuse on channel 1 earlier. And then we can verify here if those UV coordinates for the light maps are existent in the mesh over here. So if you press this button over here that says show UV overlay, it shows you, it might be hard to see on the video, it's a small black outline, but it shows you the same layout. If you change this to channel 0, then you see the diffuse texture layout, which is indeed this. See, and you can also see you have multiple channels, so technically you could build on a little bit, and sometimes that's really necessary for advanced effects. Not for a cube, so we just have 0 and 1 here, 2 and 3 are empty. So this is correct. Then if you look on the right side in properties here, it says Lightmap coordinate index is 1. This means it uses channel 1, 1, 1. If I were to type 2 here, it would use channel 2. But since 2 is empty, there's nothing on 2, it wouldn't work. But technically, if you were to make in max a channel 3, and you would do something on that, you would place the Lightmap coordinates instead on channel 3, you would be able to use that channel 3 by typing 2 here. Slightly confusing because Unreal starts counting at 0, as you can see, whereas Max and Maya start counting at 1. So 0 here means the first one, means number 1 in Max. 1 here means number 2 in Max, 3, 2, etc. So it's always 1 behind. In any case, I will go back to the default 1, and then so it uses that one, and then it says the default resolution, that's 32 right now. So most light maps tend to be very small. So a 32 resolution means it will make a light map that's 32 pixels wide, 32 pixels high. So it's indeed very small. I usually go for numbers like 64, 128, not extremely big actually. You don't really need that big of a light map usually, especially when it's kind of a dark, dirty environment. You really don't need much. But let's type something else. It's very much so advised that you type nice numbers here, powers of 2. So don't type 100, for example. Type 128, 256, 512, 1024, etc. The highest I've ever used is 1024. But I believe you could technically go to 4096, but I really wouldn't advise it. And unless you have a very specific asset, I don't see why it would do that. Just for the sake of example, so it's very clear what's happening, I'll put this to 1024. It's much too big for a cube, but just for the sake of example. And then we can have a look what happens if we add this to the level. And rebuild. So I'll add the cube somewhere in the level here. I'll copy the pillar here and the lights, so we have an example of what's going on. There we go. I'll place that here. I'm going to move the light a little bit to the right, so it also illuminates the side face. And then we have to rebuild. So you always have to rebuild, because that's the time The light you see right now is a dynamic preview light. It's not a real light, just a preview light. So you have to press rebuild light in order to bake the light maps. I'm gonna take away light maps just so it compiles faster, because the only thing I want to see is just a light map anyway. It doesn't have to be more than that. So that worked. You can see this, it light mapped. You can see the pixels here. It's not a dynamic shadow anymore or a dynamic light. And if you look in the level, then we can see that this is the one it made. So this is the top face and this is the face on the front. So that works. We've made our own basic light map. One other quick thing here. If you want to temporarily override resolution on a mesh, and you don't want to do this in the content browser, you don't want to do it here because that's the default resolution, you only want to do it on this mesh, you can also double click that mesh, and in the properties here it says static mesh component, and then you can do override light map resolution, enable, and then you can type in the override size here. So I can go back to 32, for example, for just this single mesh. And the next time I rebuild, it will do that. So those are the basics of light mapping, as many of you probably figured out. But then we have to go beyond that. We're going to get one problem. For example, I prepared a little scene here, and you can see the problem we have here. So what this is 4 times a block. This is basically just 4 times that cube. And I placed those 4 next to each other. So I got this. And they needlessly, they perfectly fit together. So mesh-wise, it's exactly matching. It's totally modular. I placed 4 standard lights in front of it, and I rebuilt. And what you get is this. It gets even worse without textures. You get very hard lines cutting through, see? And what's going on here is that the pixel from next to it is bleeding into this one. In other words, there's a black pixel next to it, and that one is bleeding in because of wrong UV coordinates. And this is what no one really seems to handle properly when it comes to light mapping, is you have to really properly UV it. So if you go look in max, and these are the 2 cubes, so I believe this is the first cube, if I was still correct. So we can look here at the UV coordinates for that one. So this is the first cube I'm using right here, the one that has a real problem. And if you look at, this is the light map for it. It's a simple flatten. I mean, technically it's correct. Everything has its own unique space. It doesn't overlap. It doesn't go outside the 0 to 1 radius. It looks fine. But it's not on a grid. So this is the thing, Lightmap Gridding. The light maps have to be on a grid. And this is a very tedious work to do. And I haven't found any real way of improving the speed of this. I haven't found any plugins that take care of this. I haven't found anything for it. But to be technically correct, they should be on a grid. And this is not. If I display the grid here. Okay, this is a fairly big grid. Let's make it a bit smaller. Let me calculate what it should be. So 0.125 divided by 2, and a lot of times divided by 2. Is that, say, let's try that. So now I have a smaller grid. This is not on the grid. And that's why you get blackness coming in. Because what actually happens is that pixels are nothing more but squares. If you really zoom in on something, a pixel is a square. Okay. So if you're gonna make lines, if you kind of cut a line across something, that line should follow the actual pixels. If it doesn't do that, if that line goes in the middle through an existing pixel, well, then you're gonna see half a pixel. And if that half a pixel happened to be black, then you will get this. So what this is caused by is it's caused by the UV coordinates of the light map are not snapped to the pixels. They're cutting through half a pixel. So this is probably half of the black pixel visible from the blackness above here. And that's wrong. So that's what we have to fix. What we have to do is we have to technically snap each and every point to the grid. Like that. So it's on the grid. Now how big that grid should be, that depends on the resolution of the light map on the mesh. So if I go look in Unreal, this has a very low resolution light map. Here's our cube. Actually, that's I overrid that here. Yeah, I overridden it to 32. So this has a 32 by 32 light map. So that's pretty much 32 pixels wide, 32 pixels high. Therefore, in other words, it's 32 little squares. It's therefore, in other words, a grid of 32. I think it's probably a grid of 16. But if you add, if the resolution of the mesh will be 32, you need to divide this into a grid of 32. If the mesh will carry a 512 light map, then you need to divide it in a 512 resolution, a 512 grid, which needs 512 lines cutting through. So the grid matches the resolution it will have in Unreal, and then you snap each and every vertex to those grid points, and then it's technically correct. So that's what I've done for the second cube here. Same cube, just different light map UVs. See, all the faces here are snapped to the grid. Now it's not 100% ideal because I have a bit of empty space left here and there's a minor amount of distortion. For example, this face is also smaller than this one, for example. But that aside, I did this rather quickly just as example. That aside, every edge is on the grid. And then you can see the difference in Unreal. So this is if you don't do that, and this is if you do that. There's still a bit of a small slight shading issues, especially vertically. There's a little bit of shading, still a difference in shading. It's not 100% seamless, but if you throw a texture on top of this, then it's pretty good. And it's in any case a lot better than this. So most especially when you work with modular meshes, you should really make sure everything is snapped to the grid. The lightmap coordinates are snapped to the grid, like I did here. That aside, also when you're dealing with light maps, is try to avoid empty space, of course, because this space is empty. It's not used. So that's pretty much a waste. For example, also if you have a very long bar or a very long anything, a very long object, let's say like a very long bar here indeed, or a pillar or whatever it is. And I very quickly give this light map coordinates. So I'll simply do this is what I usually do, is do a simple flatten to have a start with. Then you'll end up with this. Well, all of this space is wasted. There's nothing there, it's just lost. And it's pretty hard to avoid it because, well, yeah, it's simply a very long, it's long beams. But when you can, in this case we can't fix it, but when you can, always try to maximize the space you have available for the light map. So always try to maximize it. And what I also tend to do is I tend to try and make things stick together more, because all of these little holes aren't making life easier either. So I tend to snap it together. So now I do stitching on this. So now it's combined, see? So now it becomes one big UV island. That's also what I tend to do. Another thing that's important is to not have any inverted UV faces. This is something that's very hard to spot. It doesn't show up in Max really, not in a very obvious way. It doesn't show up in an obvious way in Unreal. But when you place the mesh and you rebuild, it might actually even work. It might look okay, but there's still going to be an error popping up of Unreal, the editor complaining that it's not correct. So what happens there is that you can technically invert the UV coordinate and not notice that. So again, if you look at the UVs of this one, so this is our correct one. Well, all of this is correct now, but if this would have been inverted, you wouldn't have been able to tell. So technically I can try to mirror, for example, one face, and then what you can do is I'm in face mode, I go to select, and here's a feature called select inverted faces. And if I do that, it actually shows this one up. See, so if I take a face and I mirror that in here, so I'm now going to mirror this one like that. It's hard to see, but this is mirrored. Or actually I can rotate a little bit and can talk about that as well. If I mirror something, see, now it's mirrored. It still looks fine, It will actually even look fine in Max as well if I were to use this for my diffuse texture. But in reality, this is an inverted face. See, so this apparently didn't do it. It's quite random. This also makes it even worse. It can be quite of a random process, but at some point, it will start complaining it's mirrored. Oh, still don't do it. I can try it again here. Now it selects both of them indeed. See, so it's quite random, and that's the problem. And you can't really see this either when you just look at it. But Unreal won't like this. So Unreal won't like it if things are inverted. So what I usually do as extra precaution is before I consider it finished, I do select inverted faces. I can see, okay, this one and that one. Okay, well, mirror that back, and then see what it gives. Okay, nothing is selected anymore. Now it's fine. So that's another thing to keep in mind. It's another thing that a lot of people tend to skip. And also while we're at it, now I rotated this one here. You should never rotate anything if you can avoid it. Rotating it in light maps is really bad. Try to keep everything perfectly straight. Of course, your model might have angular parts, or your model might have circles or anything. Of course, you can't avoid it then. But if you're dealing with straight geometry like this, never ever rotate it if you can avoid it. Because again, for the same reason, pixels are squares. So, I mean, you can't really, if you rotate something, you can't really make a diagonal line in pixels. If you make a diagonal line in pixels, all you really end up with is jagged edges, as you probably know. So, you will just get this. It's not a nice diagonal line, it's just steps. And for the same reason, if you rotate something in here, then build a light map based on this, you're gonna just get one big pixel blocks. You're gonna just get a blocky. It's a very blocky line. It's a very jagged edge. So try to keep everything 100% perfectly straight. Not a little bit rotated either. Everything perfectly straight. Then you will get the best result. So to recap on this, it's in between 0 and 1. Nothing overlaps. Every face has its own unique space between 0 and 1. All the UVs are on a grid. The grid is the same size as the resolution you will use in the editor. And if you don't know about the resolution you're going to use, then use a low grid. That's always going to work. Like a 32 or 64 grid is always going to work. You need to check if no faces are inverted. No face can be inverted. And make sure that everything is as straight as possible. Also, you can have some minor amount of stretching and distortion. I mean, I can do this, for example. It's not really going to show. It's the light map. It's not going to be that obvious that I did that, so it's fine. And also try to avoid as much empty space as possible. Fill it up as good as you can, like you would do with diffuse, with the diffuse UVs. And then lastly, before I will do the whole process very quickly on the roads I made, but lastly, there's one thing also that you can do. Instead of doing it in here, so I'm about to do the road. In fact, I can do the road very quickly myself first. So let's very quickly Lightmap UV the road here. I've added an unwrap. I make sure it's channel 2. And then as you can see, actually the default UV I already get is almost correct. It's a bit next to it. It's actually, you know, actually I'm gonna press enter twice. No, it doesn't want to do it. I can just flatten that, it does seem to work. And then it's there. It is next to the corner though. It's not that nice. I'm gonna try if I can snap that. So this is what I mean with being correct. So it should be on the edge here. Let's try to get that going. I'll do that. And then the other side. There we go. And then to be correct, the upper one should be there. Now it's correct. All sides match the grid points. There's empty space here, but there's not much we can do about that. It just happens to be a very rectangular object, so there's not much we can do about it really. This is just lost. So that's fine. I'll collapse it, but you don't really have to collapse it, but I just wanted to clean it up a bit, so I collapse it. I'll do it again quickly on this one. On this one, I'm gonna try to do it before it's bended, since that would make it a lot easier. So let's see if this holds up, because I do have an added poly above it, so it might not like that, but let's try this. I'll snap that there, and it probably just fits anyway. Yeah, it just fits, except it should be it's not this white. That's it. Again, lost space here, but nothing we can do about that. Close that. See if the bend survives, and that survives. That's it. So again, as you can see, I did the unwrap before I bended it, because if I would have done it afterwards, it would have been a lot harder to work with maybe. Could have been that UVs were already there and it would have survived it, but this was easier. Either way, I'll quickly export those again. Check in Unreal, how that would look if I import that. You can also always do this. You can also always right click in mesh and do re-import static mesh, because it remembers where it came from. You can see in here, this has the path to where it's located, so it remembers the source file. This one appears correct, that's what I had. So this is what I always do. I verify if the UVs show up in here to make sure it's correctly imported. The coordinate's correct already, and then the default resolution, let's say 256 for an object this size would be good. That's done. Check the curve. This one also works. Let's say it's a bit larger, 512. It's actually twice the length of one piece, so 256, 512 is a bit in between, but there we go. Save that. I'll open the scene I was working with again. There we have this. And if I were to rebuild this, it should work. However, there's also the landscape. Haven't really done the landscape yet. And then this is a special thing. Look at the landscape here. You can see this has no UV coordinates. If I press the show UVs and it's on channel 1, nothing shows up. If I look at channel 0, everything goes red. It goes red because it's outside 0 to 1. In this case it's fine, it can be red because it doesn't matter if the diffuse goes outside 0 to 1, but the light map can't. So I can't use that for the light map. What I will have to do is get a new light map for this setup as well, which I could do in Max or Maya, but I can also generate light map UVs in the editor directly, and that's what I'm going to do for this one. I'm going to first of all close the mesh simplification window, because it's going to take away all the space and I never use it. And then it says here in window, generate unique UVs. So I'm going to display that. Then I get a second panel over here at the bottom. And show the button is on, it's on. And then it says this will generate unique UV coordinates. And it says it will generate this to channel 1. And that's correct, because 0 is my diffuse, 1 will be my light map. There's a couple of simple options here, but pretty much just press apply. And then what you get is this. So it basically just did a planar map of the mesh. It's a bit rotated, which is not that nice, but since it's a very large landscape, you're not going to notice that anyway. So now we have our own unique UVs. So you can also do this in here. You can generate it in here, but it works really bad for hard surface objects. I mean, it works really well to my experience for things like, well, not really well, is perhaps overstated, but it works decent for things like a landscape, a cave, a rock, maybe a tree trunk or something. Like those kind of organic, quite random shapes, it works fine with. But if you try to do this on something like a cylinder, it'll be a complete disaster. I can quickly show you here. I mean, this somewhat works, but he broke it up here, and this is kind of like curved. The whole line is curved. It's not even straight. This is what I mean. Lightmap coordinates should be straight, because otherwise you just get jagged edges around this one. And the top is kind of random. It doesn't really work. You can try with a cube as well. So this is what I made myself. Let's generate something on top of that. And then we end up with... this might be hard to see, but you can see this is absolutely not okay for a cube, obviously. So for hard surface things, for really geometrically shapes, for buildings, for streets, for anything like that, this is a complete disaster to do. You should never use that. But for something like a terrain, it works okay, it does the job. Same thing here, we set the resolution then. Let's make it 1024 because it's really big. I'll save this and we're pretty much done. I'll quickly build out light maps just to see the light maps themselves. And get this. And I believe this works. We switch to this view, I can clearly see the size of the light map. We can also see that actually it's quite a non-uniform size. The road is a lot more detailed than the landscape. Perhaps that's not that good. What's this mode, by the way? So perhaps that's not ideal, so I'm actually gonna go back and I'm gonna bring down the size a bit to 128 and say 128 for that as well, probably. Try this again. It's still a lot more detailed, but then again it's the road, so I'll just leave it be. So that's very basic light mapping. Again, if you look in the level here, by the way, we should be able to see this light map it uses for the landscape. You can see this is the shadow of the road on the ground. And this is one road piece, next road piece. I don't know what a curve is, but seems to work. Also, one thing I should note about light maps is it will try to merge them together. If I quickly take you on the level back, it will actually merge the light maps together. For example, this one, the little cubes you have here, these 4 cubes, it actually made one light maps for all 4 objects, even while they're separate objects. You can see that this, for example, these are all cubes. It actually made separate ones of them. So it will try to combine it into large packed light maps. It packs them together. And it's just a bit of an optimization. Also, it makes a couple of weird ones, because it also does things with baking the specularity angle and normal map stuff into it, so it makes a couple of weirder ones as well. For example this, but this is all baked information using the same layout.